Hi everyone. Today I'm very excited to welcome Paul Matthews. Paul is at the same time a software engineer and a rock star. He released twice an album that ended up number 2 on the charts as a bass player, music producer, and music composer. On top of his vast experience as a musician, Paul is also a software engineer at ClearScore. And today we're going to talk about his library, Sound of Scala, which is a Scala library, Scala.js library, where you're able to encode music in a Scala DSL and plays it on a speaker. So please welcome Paul. You have an amazing background and very interesting one. Like you're a bass player. You were like a rock star in New Zealand and in London. You did like lots of things, like composing music, recording music. So I'm interested, is like, how did you transition from like this to like programming and like being a software developer? What led you to this?
I mean, to be honest, I think it's probably like necessity, really. I think that I mean, how I sort of got started with programming stuff was I was doing our band's website. I ended up doing our band's website. I was doing that like using WordPress at the time,
Mm-hmm.
and then I'd be like, I want to move that logo from here to there. Why can't I do that? So that was sort of what started me. So I got into a bit of web tech from there. But this is going back quite a bit to maybe sort of 2013. But yeah, basically, I had a few bands through my career. The first band I was in was around sort of 2000. So I joined this band, and that band, like, it did very well in New Zealand. I think it was maybe double platinum. Debuted at number 2 in the charts, and I think it was maybe like Robbie Williams at the time, which kept us out of number 1. So I was in that band for like a few years, and then I wanted to do my own band. So I left that band, and basically I sort of, long story short, I ended up moving to London, starting another band. This whole process like took about 11 years, and then the new band is I Am Giant. A bit of a plug there. You can check us out. This is my last band. Yeah, so we sort of started in London, and we got very popular in New Zealand. And we actually again debuted at like number 2 in the charts. So it was like this sort of 11-year gap where I was like trying to get the band going again. And then, yeah, I mean, obviously we're hoping to go number 1. It's like pretty funny, like 11 years to not quite get number 1 and then not quite get number 1 again. But
Well, I stay number 2. It's already like quite an achievement. Like most people will never do this.
for sure. And of course, I'm grateful. It was a lot of fun. And so with I Am Giant in 2011, it was actually Adele who kept us at number 1. So if you think about like Adele in 2011, she was really peaking, and that was sort of a whole story of its own. So
Nice. So you really started to think about programming just because you were like the IT guy of the group, and that's what started you like to think about it?
yeah, absolutely. I mean, I think that second band I Am Giant, we got to about 2014, and our lead singer left, and so I think that I just had to like sort of face the reality that the second, I put so much effort into the second thing, and it was struggling. It wasn't just that, like so we did get a new singer, but like the band changed, and we all ended up living in different countries, so that made like getting together very challenging, like logistically playing. And also I just think that the type of music that we were playing, it had kind of peaked, and it was like a new sound that was coming through. I'd adapted through changes in sound, sort of I'd adapted with the music climate through my career anyway, but I got to a point. I make a joke about it when I've been doing these talks. I'm saying like, I could have become like an influencer on TikTok, but I didn't fancy it. So
yeah, you need to
that was
adapt like
kind of it.
kind of a fashion in music, like in everything. Like so, you can't stay the same like and do the same song all the time.
I had a discussion about this with someone at work the other day. They were saying, oh, the best bands are the ones that evolve through the decades. And I was saying, well, what bands are you talking about? Like, maybe some do. Some, so you could say Coldplay. You can hear Coldplay evolve to stay current. But other bands, like, they don't. They just keep doing their sound, like, for their fans, So not every band that does that. And I don't think that our band was, well, I mean, like, we'd lost our lead singer anyway, so that was a really core component of our band. So, I was sort of at that point in my mid-30s, and I thought, I don't want to be negative, but I need to think about maybe another way to make an income as well. So
Yeah, and maybe
I
have
think
something more stable, I guess, because I guess with the music industry, like you can never really predict how much you're gonna make, or I guess maybe when you have a family, it might be difficult to.
yeah, it was absolutely that. I think I'd been like really stubborn and continuing to like try and sort of and continuing to be a releasing artist. I also was like producing bands and working in the studio at the same time, but that also changed. So I saw the evolution in the recording game. So instead of like going to a studio for a whole week and recording songs, people would start sending you their files and they'd do a lot of it themselves, and you have to like kind of fix their files. And so I think yeah, I just thought it was probably time to look at doing something else as well. So I know I didn't actually intend to stop doing anything. Technically, I'm still going. It's just that I haven't done anything for a few years. But aside from making sounds on my little music apps. But yeah,
Maybe
so
your
like
music
I
is
thought,
gonna be number one. You don't know that.
well, it's a tool that someone can use, and you never know. I mean, and that is the exciting thing about tech, right? I think where I looked at how tech had really changed the music industry, I thought, well, if you can be part of that change, if I can be part of technological evolution, that's the way to go. But really, I just really enjoyed like building out websites. So in my head, I thought, you know what I can do? I'll learn how to do websites properly. I'll go to university and I'll learn how to make websites. That's what I thought. So then I like signed up for this computer science degree at the University of Hertfordshire. And then once I started that, like I guess everything changed because they were like, oh, here's Java, and I was like, wow, actually, I could be a software engineer. Who would have thought I could build software? So
Yeah.
that was really the start.
Was it like a full time curriculum that you did, or was it like a part time you were doing, like keep your day job and you were doing this like at night, or how was it?
Yeah, it was part time, except for the final year. I did that full time to kind of get it done. That final year was actually 2020, so it was a lockdown year.
Oh
So
yeah, must have been
I had like
difficult.
time to. Well, that was yeah because all the gigs stopped and all my studio clients stopped coming. So yeah, that was obviously there was a challenging year for everyone. But yeah, I did it part time in 2015 just because I'd always been a musician and an engineer.
Hmm.
And so like doing a hard change, it wasn't even something that I possibly considered. I just thought I should get something else I can do as well, so I can keep going with my music.
Hmm.
But I think after the sort of lockdown, um, I guess I just didn't have the time to spend wanting to start a new project. I Am Giant wound up in about 2018. We did like our last tour,
Hmm.
um, and so yeah, I was still producing people up until I think 2021. But yeah, like basically, I got like my first graduate job, which was at Fujitsu, on their graduate program, and I think I must have been like the oldest graduate they ever took on, but thankfully they took me on, gave me a start. So once I started there, I kind of stopped taking studio clients.
I say,
But I did spend a lot of time in the studio, like doing like multiple vocal takes and tuning the vocals and editing the vocals. Like it was like studio audio engineering can be like another level of tediousness. I think anybody at work would say to me, like for a similar task of tediousness, they'd say you've got to write a script for that. It was really like manually replacing cut and paste and things like that. Like yeah, you
you could
guys would never
automate
do it.
quite a lot. Like,
Yeah, I wish I could have automated the vocal tuning process, but no.
cool. So when was your first interaction with Scala? Was it in uni, or was it when you got when you went to ClearScore?
It was totally when I went to ClearScore, I hadn't even heard about Scala. I hate to say it. This is in June of 2022.
Yes,
A
less than two
recruiter for
years ago.
ClearScore reached out to me. So
Right.
sorry, what was that?
I was saying like less than 2 years ago, so it's like quite recent.
Yeah, yeah, yeah. So they reached out to me. Oh, there's a great opportunity, and you can use like Scala. It's a really microservice architecture. It's really great. So I was like, okay, I'll Google Scala, and so I googled Scala, had a quick look at it, and yeah, the first thing I saw was like the print line. So it didn't have the system out dot print line because I'd come from Java, and I was like, oh, that's a very sensible thing to do. And so then I looked at Scala quickly, and I mean, I'm sure a lot of other people have thought this. I was like, oh, looks like someone's trying to fix Java. Looks really good. It's like a modern Java. that was my initial thought, and of
Yeah.
course now that I've got to learn a lot more and meet a lot more people, I'm like, okay, it's not quite that, but
No, but I mean, definitely there is one side of it that makes it like simplify, like maybe not simplify, but I think like shorter, more concise Java is definitely one thing that I think many people drive to Scala. That the fact that it's much more concise, you can express things much more quickly. Um, and so,
yeah, well,
how was your?
I watched.
Yeah, go ahead. Sorry.
Sorry, yeah, I watched your interview with Lee Howie, and he was saying about you guys were both talking about the vastly different ways you can do Scala, you can use Scala. So obviously object oriented is one application of it. So
Mhm.
coming from Java, then I was thinking in an object oriented way. Going to ClearScore, then I was introduced to the functional side of it, and so obviously that's the whole thing I ended up focusing on.
Was it because you found it more interesting, or was it because it was like how it was made at ClearScore, and so you just keep doing?
No, actually, at ClearScore, like there was like a few different stacks. We had like a sort of more sort of Java style sort of Akka slash Pico stack,
Mhm.
and we also had like the sort of type level functional stack. I think yeah, I mean we had some training going on at work as well, and so we were getting some Scala coaching from Noel Welsh.
No, yeah, nice.
And he was really great, and so he sort of introduced me to functional programming, and I guess I just got right into that. I was reading his books, and this is how this whole music thing for me in the Scala started. It was just an exercise in one of his books, Essential Scala, using algebraic data types to model different things. And of course, there was model JSON with the algebraic data types. Okay,
Mhm.
cool. So that's a common application. And then he said he had an exercise to try and model music, and he left it quite open to interpretation. So of course, with my musical background, I thought,
You went deep.
surely at least I can do this. Yeah, I did go deep. And I don't think well, I never did I think to myself, I'm going to make a music library, or I'm going to start doing all this coding and music. In fact, I was more thinking, after doing 25 years in the music industry, I'm just going to work in fintech now. I was like, I wasn't thinking I was going to do a whole lot of music stuff, but it's just happened, and
Yeah,
I guess it's natural.
yeah, one
Yeah,
step, and at the end you have a product that is
yeah,
actually quite nice. Yeah, that's a nice feeling, isn't
yeah.
it?
Because I mean, and also, when you've been writing music for a long time, and you get it's like a song that kind of works, and you get the satisfaction for hearing the song kind of come together. If you combine that with seeing your code compile and then having it work, you sort of get the best of both worlds.
I can imagine that. And so how did you find the learning curve, like when you like learn Scala? So I guess it's quite good that you had like a trainer, because I think most people don't really have this luxury. I think in most companies don't necessarily have a training program in place. But for you, how was your learning curve? Was it okay? Or was it like banging your head against the wall, or was it relatively smooth?
Yeah, definitely not. I wasn't banging my head against the wall. Some things were easier than others.
Hmm.
Um, And I know there's been quite a bit of discussion in the Scala community about the on-ramp, and then there's
Yeah.
a bit of an impetus to make it easy for people to get in. Then when you want the depth, all the depth is there. So I kind of feel that there was that for me. I remember going through all the basic stuff. The first thing I did when I got the job sort of offer, I was like, oh, I better learn Scala now. So there's like other languages. I can think of maybe Java. I just read a book on Java and then just programmed Java, and there wasn't any real pain. Um, then I remember I just got the Rock JVM bundle on Udemy before I even started at ClearScore, and I started going through that.
Hmm.
And then I remember getting to the advanced stuff, and I can distinctly remember when he first mentioned Monad, and I watched it. I was like, what?
What?
Hang on a minute. What's going on here? So little did I know, how much was to come, all that sort of stuff. But yeah, I think to get going, it was fairly okay. But you know, deciding to learn the type level stack, that was not something that was going to happen in a month
Right.
or even a few months. Like that was going to take some study. So I just kept working away and then doing the role that I had and the task that I was given at work, but getting through things and just went through the books. And when we had also like a bit of a study club at work where we were going through the Cat's book. But yeah, I distinctly remember one of the senior engineers at work saying to me when I first arrived, and I said, "What should I do? Echo or should I do Pico? Should I do type level stuff? Cat's effect?" And he was like, "Why don't you redo your tech test? Do one in Echo and do one in the type level stack." No, he said, yeah, "Learn Cats and do one in Cats." And he just said it like offhand like that as if it was something I was going to do like next week. And so, obviously it took like a long time to, over the next year, whatever, I kept like looking, reading the books and putting some stuff into practice and just, getting that knowledge together. But, yeah, I can understand that, I can understand that. And potentially I didn't need to do that. Like I probably could have done my job without but I wanted to learn as much as I could about everything. So I just kind of immersed myself in it.
I understand, but I mean, I think there is not one way to learn. I think everyone has different. This is one thing that makes it a bit difficult about teaching is that some people want more practical stuff, some people want more theoretical stuff, some people like more. I think ACA or object-oriented or functional programming. I mean, it's really like subjective, right? And for not for everyone, it's going to be the same. But what would you recommend, like for someone like new, like just a fresh graduate student from uni who just has some Java experience? What do you think is the best way, like to start learning and be productive in Scala? Like if you take essentially like you have 2 years experience now, if you were to come back, what would be the advice you would give to yourself?
Yeah, we also have like I think at work we've been like sort of doing sort of Scala training for the apprentices at work.
Mhm.
And so we've had a chance to like look at it again. And I think dividing up your theoretical learning and your practical learning, like I think having a project to do. So maybe with this music library as well, this is been about trying things for me. Like I'm still like learning new libraries and learning how everything's working together. So the best way to, like, for example, we could talk about like a monoid or a semigroup and a combine. Um, and the first iteration of this music library I had, I wanted to combine some notes. At that point there, I ended up using a semigroup. I had a point where I needed like an empty case, like so I could fold it, so I could fold a note.
Yeah.
And at that point there, instead of a semigroup, I could use a monoid. So I think that there's like a first-hand application for some of the stuff that you're learning, and I think that's invaluable. Like if you do your own project, you create some problems, and then you have to like find the solution, and that's when stuff can start, sort of fall into place. And I think that, to be honest, it's a little bit similar to music because with music, at the beginning you start learning your scales, but you'll be like learning and practicing these scales for maybe a year or more sometimes before you actually just notice that you're using them in your playing and in your songwriting. So it's one
Mhm.
of these things you do at the start. You don't really know how you're going to use it, but then later on down the track, it all sort of becomes apparent.
This is something I always wonder, I have the impression that school and maybe musical school in the same way has a slight advantage over like programming because it's kind of a mandatory curriculum so that, like teachers can go like kind of theory first and like teach you like the fundamentals and you don't necessarily know why you need this stuff in the first place. But then, down the line, 2, 3 years down the line, you're going to essentially like, be able to use them like without thinking and see the application. But like I feel with
100%.
programming, like no one really nowadays has the patience to learn abstract stuff for 2, 3 years without knowing why. So you kind of need to have like a practical application. So I don't know what's the best way. And I guess maybe also school needs to learn how to motivate kids to find this stuff interesting. So yeah, I'm not sure what the best way for teaching generally.
Yeah, I feel that a project like actually working on stuff. So definitely when you get a job, you have to work on a code base.
Mhm.
There's your mileage or your flying time right there. It's not going to cover all the cases, right? It's going to cover the roles specific to what you're doing. So you need to like broaden it a little bit. So yeah, having your own projects and getting little things to do. these really help. And I do have to say, I don't think I would ever have learned any music theory if I wasn't playing in a band. So because
Mhm.
I started playing in a band as a teenager, I had to like learn, I guess, the science behind what I was trying to write and what I was trying to do. And I remember that being the most frustrating time of my life. It might have been also because I was a teenager, but maybe through that period I learned some kind of perseverance or developed some tenacity. I'm not sure, but definitely wouldn't have learned all those scales and stuff and all that theory if I hadn't been, you know, a musician playing in a band. Because at the times, I remember I would give up sometimes. I was like, oh, that's it. I'm not looking at that anymore. Maybe with chord theory, but then I just keep playing in the band, and then I'd come back to it, some months later or something. So, in terms of in terms of programming, I definitely think that um, doing like little side projects, just spinning up code from scratch, creating things from scratch, and just making mistakes as well.
Yeah.
Not having like analysis paralysis, just getting on and putting some stuff down. So like the Sounds of Scala music library. And it's up now. At some level, I guess it's semi-usable, but it's like a work in progress, and there's things in there which are just it's an iteration. So
Yeah, I guess there's no like end to it. Like a whole API, it's you continuously rework. You can and you discover new stuff all the time. So
absolutely, yeah.
so talking about Sound of Scala, so what is the goal of this library? What is the use case? Like other than for you that it's a pet project, I understand, but like let's say for someone else who is considering like let's say doing music in Scala, so how can they leverage your library?
Mm, I think uh, the most simple use case would be maybe a student like I was who had made an ADT for music notes and just wanted to play some audio really quickly. Just import a library and play some audio. So this is kind of the vision I have for it is to make a Scala specific library. Someone can just instantiate a sampler, load some samples and play the samples. Or they can go deeper, they can instantiate a synthesizer, or they can instantiate the components that make up a synthesizer and then compose those. So and then they can use that to build anything. You could build like a little iTunes app to play some songs, or you could build like I've got some apps I'll show you in a little bit, like a drum machine app, or um, this drum machine app's one where like I used this while I was doing a rehearsal. So the drummer didn't turn up, so I needed a little drum machine. So I used an online one. It's just a simple little drum machine you can load up in the browser. So I just made something like that. But the idea is that you'd be able to like extend that. You could build something like GarageBand or like an actual recording, you know, um, digital audio workstation type thing.
Fine, okay, nice.
Maybe like another bit like say virtual DJ or something. You can have the turntables on the screen and just I guess any kind of web audio application really. Potentially you could use import the library and use it for games. And I'm sort of going down all the paths now. Um,
Yeah, I was thinking
you
that
did mention as well.
I haven't played this sort of games for a while, but like the last musical game I played was like Guitar Hero. So I was wondering like if it's potentially like you could use it, connect your library with something that plays the music and something that catch the players choosing the chord, or I'm not sure.
Yeah, I totally think that's possible. I totally think it's possible. Like I did kind of uh have an idea of like something for children to play, like almost like do you remember that game Simon Says?
No, I don't think so.
Yeah, see, I'm showing my age, but like it can emit some tones and there's colored buttons, and so you can use your ear to push the button when you hear the tune. So like
Hmm.
you could do like basic music kind of training and it's kind of fun, like a simple musical game.
Yeah,
There's
definitely.
all kind of little ideas I've had, but
So just so to understand a bit like your library, so if I understand correctly, there is like a model like where you have like different like representation of music, like what's a musical note, how to compose different notes, different instruments together. And then there is something that kind of interpret the song that you create and like plays it on the audio. Is that correct?
yeah, that's right. Yeah,
And
yeah.
so I was wondering, so
So
why do you think Scala was a good choice to like do encode the music? Like, I mean, I understand that because it was a language you were doing at the time, but do you think there are other reasons why it's a good choice for this?
Yep, I do. I mean, I've got these like actually written down. Like,
Yeah.
there's, I guess I would say, um, conciseness and expressiveness,
Mhm.
type safety, so static typing, the fact that you can create these custom operators and syntax, functional programming features, and library support. You've got all these you know Java and JavaScript. Well, obviously, I'm using Scala.js. So you've got all these JavaScript and Java libraries you can use. So yeah, with the like the syntax, you can custom operators. You can make like these. Well, I've done it with my DSL a little bit. You can make sort of music-related constructs that look like natural language. So it can be kind of like an intuitive DSL for sort of even people who are like beginner programmers or who haven't seen the library before.
Yeah, so Scala is very good for creating DSL because as you said, the custom operator. So you think that at the end it can look like something like a musician will know how to use kind of intuitively without necessarily like a huge background in computer science or Scala.
Yeah, absolutely. I mean, something I've been trying to do is write a DSL. I was working on it on the weekend. Like I was working on the sort of drum language side of it. Have something that a programmer who doesn't know a lot about music can read, and and vice versa. Someone who's from a more musical background doesn't have to have a very a really great programming knowledge even. So just try and make it simple to use. I think this is one of the challenges is thinking about how it might be used and making it as simple as possible. One of the things I did recently was I used what's it called when you publish local. So I published the library locally and then imported it into my project. And then straight away when I went to import some of the classes and use them, I was like, straight away it's a bit clunky. So it gave me some perspective on how I could make the API a little bit. Start thinking about how I can make that simple and easy to use.
I understand. And do you think it will be possible to do like a short demo just for people to have a look at how, essentially how you can like code a song and how you can play it using your library?
Yeah, absolutely. What I'll do is I'll share this. I can show you like what I was talking about was the um sort of drum machine I've been working on. So
Mhm.
let's have a look here. Maybe this one here. Here we go. Yeah, so this is a little app.
Nice.
Um, I'm sort of like reinventing the 808 drum machine from the 80s.
Oh, wow, fancy.
So
So
yeah, I
is
mean
it a
this is cool,
Scala.js
right?
application, this?
Yep,
Oh, amazing.
Scala.js application. Yep, and yes, I can program in the beat, and I have the advantage, right? Like back in the 80s, they were restricted with their cost overheads of having like a certain amount of switches. Obviously, in the virtual world, we can just do anything. So, but you can see the drum pattern here. So I can program in like a really basic beat. Yeah.
Mm.
Can you hear that okay?
Yeah, I can hear it very well.
Oh,
So
cool.
each
Yeah, I can put
line
some swing on it.
is a different kind of instrument, I mean, a different element in the drum. Is that correct?
That's right, that's right. And these are these things that when you're like implementing something, initially I didn't even have these names here. And then I
Yeah.
realized, well, people might not know what these strips are. So it's like one of those little oversights. As a developer, sometimes you forget. So this is the kick drum. This is the snare drum, the crack. But there's also this iconic hand clap that the 808 drum machines had. And it sounds a bit like this, actually. I'll make it a bit slower as well. So now this app here, I did using Hone.js. So this was like wrapping a JavaScript library. This is what kind of led me to want to develop, a dedicated Scala-specific music library. Was that I wanted to sort of get some fine-grained control and do everything from scratch.
So each number, is it like one bit of your tempo? Like, is it correct?
Yeah, you know what? It's broken into like sixteenths, right? So this is a beat here, 1, 2's here, 3's
Ah,
here. So the colors, the red, orange, yellow, and white. These are the beats, 1, 2, 3, and 4.
mm.
And then these are just the
This is like a
16th
quarter.
increments
Yeah.
of those. That's right, that's right. So these are quarters, and these are sixteenths as you're doing music theory. So that if you count this, you'd actually count this like 1 E ender, 2 E ender, 3 E ender, 4 E ender. So this is when I used to give
Understand.
guitar lessons all those years ago. That's what I used to teach my students: 1E and a 2E and a 3E and a 4E and a. So this is kind of how drum machines have been, I guess, especially back in the 80s. This is how they were implemented. If you want to do 30 seconds, well, it's going to be hard.
And
But then if you wanted to do 30,
so this graphic UI, does it translate to like your model, like you say, like a note, a B note, or does it translate to this, or does it go straight to Tone.js to place it?
no, this one here, I actually I do go through my DSL. I can probably I can look to share my yeah. So here's like an example of so for that beat that I just had then, it is actually quite similar to this. So and what I was doing was with the like those buttons, I was essentially having like a list of like I can draw it out for you. So it will be like this. So I made some adjustments over the weekend. Here's like a basic kick drum,
Mm-hmm.
which looks like this, an atomical musical event. And I've got these little symbols, KK. So a KK for a kick. So you can see here, I've got a drum stroke with, how long you play it for, how loud you play it for, what voice you use. And this is one of these things I thought. I was like, I'm not sure if everybody else can read that. Like, if you didn't know the context, would you know what KK stood for?
No, but to be honest, I have no musical background, and so I don't even know what's a kick, what's a snare drum, or.
Okay, yeah. That's okay. Well, so a kick drum is the big one that you use your foot pedal on. Dub, dub.
Mhm.
So it's the one in the club with all the bass. Yeah, dub. It's possibly the most famous drum. It could be a controversial statement, but yeah, I think the kick drum is pretty essential. So if you imagine those 16 buttons for the kick drum channel,
Yeah.
it would look like this, like 16th, and then I just actually put these in a list, really. And so in that list, I would have like 16 of these rests for a 16th, and then when someone pushes the button, it swaps out the rest for a. So
Mm.
a rest would look like this, plus rest 16th. I can probably let's have a look. Okay, so this is going to be like 1E. It's going to be pretty quick. I feel like maybe we should try and show you. Actually, we can just repeat that.
So if I understand correctly, the kick drum 16th is like toggling on the button, and the rest is like
Yep,
toggling off the button. So this is
yep,
like a
that's
0,
right. Yeah,
1, brilliant.
yep. I've definitely thought that like programmers would understand like a rest as like an empty,
Yeah.
like an empty note. Yeah. So it's just a pause, really. So if I do that, let's see if I can rest this running. So in here,
Nice.
yeah. So there's those pulsing 16 kicks. So yeah, that's basically how I did it with that drum machine.
I
I
see.
still use the DSL. At that, that's probably at that point that I was thinking, it'd be good to cut out the JavaScript library and just go straight to the web, because the JavaScript library already uses the Web Audio API. So
Mm-hmm.
that's like an abstraction on the Web Audio API. So I thought let's just create our own, library specifically for Scala, for Scala and Scala.js.
Yeah, nice. And so what's very cool with this is that essentially the music that you create is like a data structure, right? Like it's nodes, different kind of nodes. So you can manipulate it. Like, is like any use cases where, I don't, because I don't know anything about music, I don't know if it will make sense, but like, when you have a list of numbers, you can do +1 to all the numbers. So could you imagine that, would it make any sense to, let's say, iterate over your tree or your list of nodes and like change like all the A's into a C, or do, I don't know, like add some rest in between? I don't know. Is there any meaningful transformation you could think of?
Yeah, I definitely think so. The transformations I've currently done, I've got like yeah, I'm kind of at this point where I'm figuring out how I how I turn some of these structures into like I guess a monad or a functor, so I can have a map and a flat map on it, and I can apply some transformations like that. I haven't got that at the moment. At the moment, note is part of like a musical event,
Okay.
and so this I kind of changed over time as well. Initially, straight from the book exercise, I just had musical event. I'm actually, at the time, I called it like an outburst, like kind of like a musical outburst, like so this is my first thing, but it got confusing when I was explaining it to people. So my kind of joke wasn't really translating to, it's just confusing people. So yeah, I went for like musical event, and then I had like rest, note, harmony, melody. But as I was working with the sequencer, or the scheduler, I realized that in terms of time, all these other events happened at one point in time, whereas the melody was the one that happened over time. So then I felt that, okay, this is like, so I changed melody to sequence. It's like I changed it to sequence, and then I had like a sequence and an atomic musical event. So that was the first differentiation. And so then at that point I had like a kind of nested data type.
Yeah.
But yeah, I mean, you can see all this in the code. And then with sequence, initially I just started with, you know, music event left, music event right. So we had this recursive data structure. And then I was thinking about that over time as well. I was like, well, you don't actually, it's not actually like a binary tree, because we're never going to have the left tree. I was like, it's only going to be
It's more like
the
a
first,
list or
yeah, exactly. It's a linked list, because like time only ever goes that way. I mean, much as we would like it to go that way,
yeah.
we're restricted to going that way in time. So yeah, I sort of changed it to a linked list, and again, yeah, just I've been playing around with, I guess, some sort of basic transformations on that. Like I did a reverse. Well, I did a reverse as part of like making like a tail recursive append. So if you know the linked list, whatever, you know, it's not tail recursive if you're just adding the head to the function again on the tail. So this is, I mean, you can see that in the code too. It's straight out of like these like exercise books and stuff. But
Yeah, data structure. It's
yeah,
cool.
yeah.
So if you don't mind, like I would like to go a bit deep into like, because I know nothing about music, but I've always been like interested about like the names and how like by the way, one thing I like about your talk is that that you made at Scala.io is that I actually didn't know that there was different names based on the language. Like French, we have do, re, mi, fa, sol, la, si, do, and in English you say A, B, C, D, E, F, G, which is much simpler. So why there are only, is it like 7 different notes? Is that correct? Like, is it like from A, B, C, D, E, F? What's the last one?
Yeah, G, A, B, C, D, E, F, G. Yeah,
Yeah,
this is like I discovered this at the talk in France too, when the guy in the audience said, we don't call notes that. So I just assumed it was A, B, C, D all across the world. So
it's so simple, like it makes sense.
yeah, yeah. I mean, yeah, there's some I'm not sure how they originally designed it. I don't know that much, but I just know that there's a relationship between like a frequency of a note. So you can say like an A note. I think it's an A4, A3. It's like 440 hertz. That's like constant pitch. So
Okay.
they've settled on 440 hertz as an A, and then like from that you have you go up in like semitones or half steps, which is like, I think there's an equation for it. I might get it wrong. I think it's like 12 root, I think, of 2. So something like that. So
Okay, so
440,
it's like
12th root.
each note is a frequency.
Correct.
Yeah. So that's how you can recognize, because one thing I always wonder is like, how can you say like, this is an A for like a drum, and A for a guitar, and A for like, I don't know, if I clap my hands. I just know. So is it because it's the same frequency for all these different instruments?
The fundamental frequency, yes,
Yeah.
because the one thing that does happen is when you play like an A on a guitar, there's actually like overtones and other sounds mixed in it. So if you generate a sine wave at 440 hertz, that's a pure 440 hertz signal. But if you play a guitar string there, or a piano as well, like there's other frequencies and overtones and stuff mixed in with that. But the core fundamental musical frequency is 440 hertz. like you're talking, I think, about sort of pitch recognition. And normally what you do as a musician is you develop your relative pitch. So you'll have like a note. You can say da ba ba. Like I know that it's a fifth. Like a root, fifth. And I can tell you that because it's like the beginning of Star Wars. Bum, 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 bum. So like,
I
yeah,
see.
you develop your relative pitch. Yeah.
So
And
yeah,
some people,
as long as someone tell you, okay, this is 400 hertz, essentially, you can say, okay, this is 440, then you can calculate the difference.
yeah, I I have developed. Obviously I did it for 25 years, so I've got a fairly good like orientation, right? But yeah, it's like kind of like needing a compass, right? Once you have a compass, once you know. But yeah, there are some people that can just recognize the actual frequency. So I had a friend, he was a guitarist in I Am Giant. His name's Asia, and he had like perfect pitch. So I remember we were in the van, and I started singing like I started singing this Phil Collins. Yeah, how can you just walk away? And he goes, oh, no, no, no. I was like, how can you just walk? So he like corrected me on the
On the
starting
key.
note, and I was like, wow. So I didn't bother finishing singing the song. I was like, okay.
I
Yeah,
understand
but
that.
he just he knew he could recognize the exact pitch. So, and I do think that maybe some people who play like non-fretted instruments. So obviously with a piano, you've got like discrete notes, right? Like
Hmm.
you've got keys, and it has a
Yeah,
say on a violin, you have no frets. So it's not a precision instrument. So you can actually make the entire range, the entire frequency range. So you can play like 445. You can bend your finger. Well, actually, you can bend your finger on a guitar too, but this is beside the point. But so like I think that some of these like violin players and stuff,
they have more
they
freedom.
may develop. I think they may develop the pitch recognition more because they have to place their notes
Mm.
with their
Yeah,
ears. Yeah.
yeah, definitely. I mean, I always heard that violin is one of the most difficult things to play. Like, well, I guess it's maybe
Well, I
there's some
think
controversy around it, but
no, I think the violin is one of those instruments where it's one of the easiest to make sound absolutely awful as
oh
well.
yeah,
Like
yeah.
when you're learning it, it's just scratching and but when I've heard some players just breathtaking that they could make it sound amazing. So
And so coming back to the note, so I heard so there is also this because it's kind of cyclical, right? You say like A B C D E F E G F G, and then you come
yeah,
back to A,
hmm
right? I think is it an octave? What you said, like a
yeah. hmm
yeah. So why is it
So if you
cyclical? Like, do you know?
I don't actually know um the maths behind it. All I know is that if you've got A, it's 440 hertz. The
Mm-hmm.
next A up is 880,
It's
and then
double.
the next A up is yeah, that's right. And then the next A up is well, don't make me do the maths. Was it
Yeah,
1720 or whatever it is?
I see.
So
But the fact that we said
it's
it's the same note, does it mean that it sound the same? Like A with one octave and one A with two octaves, does it sound the same, or is it like a
yeah, it does just like one thing higher. Do you want me to show you?
yeah, yeah, I would love to.
I think I can show you. So here you've got like it's like an E. Here
Okay.
you got the next E. So that is the same note, but just a whole like revolution higher. And it actually sounds the same, just an octave higher. So yeah, so I do hear it as being the same,
Okay.
but just yeah, like I say, so like A B C, sorry E F G A B, sorry yeah E F G A B C D E.
I see. Yeah, I think you're
Probably
probably
normally you go from C, so you go like C D E F G A B C.
yeah. I guess I may not have a very good ear, so I'm not. I mean, I hear differences, but I think that what I struggle is to recognize a pattern. Like, but I guess like you need to be a bit a musician.
I'm not sure. I think the octave was one of the first things that I found easy to learn. I
Okay.
could at least like find a pattern a pattern on the bass. Like it was one of the first intervals that was okay. Well, at least I know that's the same note, but a whole cycle higher.
Yeah, maybe I should do some kind of games like a note recognition, and maybe you start to detect a pattern after a while.
I'm not sure. I'm not trying to trick you into working on the library, but I'm quite sure if you did some, there's actually a task that needs to be done, and I'm pretty sure that after doing it, you'd know it for the rest of your life.
Yeah, it's a good motivation, definitely. And so another aspect I was very curious is that, okay, so I understand that this frequency describe a note. So that kind of makes sense. That's why you may have the same frequencies through different instruments. But how do you encode an instrument digitally? Like, how do you say, like, okay, I have, let's say, a song that is A, C, D, like a couple of notes that plays one after another. Why then you say, okay, this is ACD for guitar and ACD for drum, and it's going to sound completely different. So you need to somehow encode what each of these notes represent for a particular instrument. So how does it work?
Yeah, I've got two ways. There's two ways that most people encode an instrument. You use a sampler, and so you
Okay.
sample the recordings of that instrument. That's probably the best way to do it.
Mm-hmm.
I think that's pretty much what all the good sounding virtual instruments are. They're like samples of real instruments. The other way is to do like synthesis, but like we've kind of moved away from the idea of like trying to recreate real instruments with synthesis. We've kind of gone more to the you know idea of creating interesting sounds with synthesis and letting that be its own instrument, its own voice. So synthesizers have their own sound now. Like that drum machine I showed you, like they were trying to make those drums sound like real drums. And that was the closest that they could get using, oscillators and filters and things like that. So nowadays, synthesizers are an instrument of their own. And other instruments, like say the guitar you heard, that was actually samples.
I understand. Yeah. So you're not trying to essentially create like a song that will sound exactly like a real one, but you want to, like, I mean, a real one made with a real instrument, but you want to just make something that sounds nice with what you created.
That's exactly it. Yeah.
Yeah, it
I
sounds,
mean, I
yeah.
can show you. I can show you like an example of some synthesis, on the actual library. And I'm not. Tell me if I'm going on too much.
No.
But
Of course, like I think like this is the most interesting part, like to see how it
yeah.
works.
So like this is how you like create a very simple synthesizer. So you start off with these like oscillators. So you start this off here, and you start with some sine wave. Well, the sine wave actually looks like, well, sine wave. So it
Yeah.
sounds like that. You have square wave. Sorry, sawtooth wave. Square wave. Triangle. Yeah. So what we can do is we can mix those together, and we can get like a sort of compound signal. We can change the pitch. So that there's like what a violin player does, right? They can move up and down the fretboard like
Right.
that.
Yeah.
But we're more interested in having discrete notes. So you got a low pass filter. We can settle there. So this is a sound. We've created a sound now. Maybe it's not nice. I'm not sure. It's subjective, but yeah, I think if we play it into the context, yeah. I mean, I
Nice.
don't know. Do you think it sounds a bit better?
Yeah, I really like it. It's
Cool.
impressive. For
Yeah.
me, complete magic.
Oh, awesome. You know what I'm going to do is I'm going to correct myself on that third octave of A, so 1760. Otherwise, I'd have to go back and so 440, 880, 1760. Otherwise, I was going to worry about that. I was going to have to tell you to edit that out. But now that we've got that out of the way, I can move on.
Nice. It's amazing. Cool. So yeah. Okay, so now I understand a bit more like how is it even possible to do this? But one thing I found, so another interesting aspect I thought about this data representation of music is that we do actually already have like physical representation when you have when you learn a lesson. Like it can be like a musical sheet, or like I think in guitar it's something different when you see like where you need to place your fingers. So is it possible to potentially translate your representation you have in Scala into a more traditional representation that people use for decades?
Absolutely. Yeah, definitely. I haven't done that. This is one of these things. Maybe this can be, because we've got a couple of Google Summer of Code projects in this year. We're hoping to get, have those approved. So maybe next year we could try that again. And one of the extensions can be to turn, our DSL into, score. So actually turn it into like, music notation and also tab. I mean, there's loads of applications already doing it online. So I don't think that it's going to be too hard to do. I actually, yeah, at that talk that I did at Scala.io, there was someone in the audience who asked me about that, who said, are you going to do notation? And I said, well, you know what, I don't really think it's in scope because most people are using digital audio, to write music and stuff, and most of them are using like a matrix editor or they're like using the UI to drag notes around. They're not really, using traditional notation is not as prevalent. You don't need to do it. There's nicer, easier ways to do it.
I see.
And he was okay. And then I met him in the hotel the next morning for breakfast, and he was like, "Oh, well, actually, I play the oboe, so I only ever read music notation." And then I felt a bit bad because I was kind of like discounting it. And of course, like, yeah, it's still notation's still a very widely used. Everyone in the orchestra is using it, and yeah, so it would be a cool functionality to add at some point. But yeah, and maybe someone else
And I
can do
think
that.
it's a very nice use case of like interpreting like one like essentially DSL into another one, like a transformation that, yeah, I mean, I'm not sure like how like the real business use case, but it's a nice demo kind of like how you could it's very cool.
For
And
sure.
another thing, so like when you look at some people who have like a studio, like a studio for musical recording, I always find it impressive the amount of knobs and like things they can tweak to change something. So are they? No, I'm not going to say like are they, is it fake or real, but like is it possible to like encode all of what's in the studio like digitally, or I mean I guess yeah.
Absolutely, that is the plan. Yeah, to recreate all that sort of signal flow. And don't I always say this to people when they talk about the mixing discs, they're so big and they got all the knobs on them. Like you just got to think of each of the strips as a component, and then you're like just looping. It's the same strip, like but just repeated many times. And at the top you might have some equalization and some gain to control the volume, so you sort of subdivide it. So um, that's where I think that the project that we have in for creating the web audio graph, um, that sort of lines up with the classic studio plugging things in. You take your guitar, you plug your guitar into an amp, you put a microphone in front of the amp. The amp goes into the mixing desk. The mixing desk goes to like a master bus. You then would, this is an analog situation. You would then feed that out to the tape and record onto the tape. So all these components, you plug them in. And I think the idea is that we would do the same thing, and we'd have these like nodes in the graph, and then we'd like compose all these nodes together. So I think at this point, we would be using like we're looking at using some of these classic combinators, map and
Yeah.
flat map and combine and yeah,
Yeah, because it really looks like
filter.
a pipeline of transformation that you apply like one after another. So at least that is how you describe
Yep,
it.
absolutely. Yep.
Cool. That's amazing. And so you mentioned this Google's Summer of Code. So you said that you're going to start this year. Is that correct?
Yeah, this is my first year that I'm involved in. Mm, Noel Welsh actually approached me and said, because he's always been sort of mentoring me, and I do Scala Bridge with him. I
Yeah.
mentor at Scala Bridge, and so he said, Sounds of Scala would be pretty cool as a Google Summer of Code project. If for a graduate or a student, university student, to, do a sort of discrete task, and they can sort of add to the library and learn while they're doing it. So I mean, he said, would you like to co-mentor? And I said, yeah. So basically, we just it's sort of like the organizations. The organizations apply. So we submitted our ideas to the Scala Center, and then once the ideas will get published for all organizations, then the students go through it and pick the projects that they think they'd like to do. And at that point there, you sort of meet some students, you talk to some students, you decide, you both decide whether you think you can work together to achieve the project goal,
Mhm.
and then you submit that. So I think now we're just waiting for I think it's about another month, and then we'll find out whether or not it's been approved.
Okay, so you're at the stage where who is approving this? Is it the Scala Center or is it the?
Yeah, I think before it goes to Google, I think the Scala Center like refine the projects that they're going to put forward as the organization.
I see.
The way I understand it, the organization has so many available slots. I think this is maybe the third or fourth year the Scala Center have had submissions.
But I think it's a very cool project. I think it's perfect for beginners because it's very concrete. I think especially when you do like back-end development, quite often, like when you try to explain to your family what you do, like essentially you take some data here and you put it over there. It's very abstract, but here you can see it, you can hear it. It's
It
pretty cool.
wasn't. Yeah, I think that's possibly one of sort of things that Noel mentioned. He thought that the sound library has good like application like for learning Scala, because
Mhm.
you have people who've got like a basic musical background, and then straight away you can make some notes come out of the computer. And I found this too actually with Scala. I was introduced quite early on to like Scala.js and like Laminar, and then I can make a UI. So when you see something physical in front of you and you can move things around in that, like yeah, it just gives you some like maybe concrete results, or
Yeah.
maybe some sort of exciting results. Yeah,
Yeah, it's definitely
and I
motivating.
think that's the same with what with what Dave Smith's doing with Indigo. Obviously I've seen Dave, did an interview with Dave, and I've seen Dave's talks and stuff. And yeah, like you can do some fun stuff with Scala. Some sort of engaging, creative ways of using it.
Yeah, I mean that's what's really cool is that I do think you can get lots of job and you can get money from like doing like a engineering job, but it's difficult to motivate someone someone especially like say a young graduate to do this. Except that maybe the monetary aspect of it is motivating, but the rest might be like as I said, it's quite often you move data from one place to another, you apply some transformation, but it may not be it's interesting but not the most exciting stuff. So it's very cool to have this fun project, and it's super interesting to work on.
It, it makes a lot of sense. Yeah, so I think we're talking about like with graphics and stuff. You're talking about like visual stimulus, and with the sound, you're talking about like you know audible stimulus. So yeah, I mean, I think it's another. Yeah, like you say, a good way of attracting people and keeping their attention, having some sort of more enjoyable aspects to learning the language.
And I'm sure in this area there is probably you can potentially write like an application on top of your library that has a real use case, like either for for yourself, or can be like maybe you could make something that you could potentially sell, like I don't know, like some kind of games around music, some kind of demo application. It is possible. So it's really cool.
Yeah, I'm definitely gonna finish up my drum machine. I'm gonna like migrate the JavaScript library to the new library once we're at the stage where it's usable. I mean, I could almost do it now, but I probably want to have the library packaged and on a repo where I can just import it at that point there. That's kind of the next milestone, I think, having something usable that people can import. Of course, yeah, like you yourself, you've written libraries, and obviously like I use Monocle, so like I know that you know what it's like with you're releasing a library. The idea of introducing breaking changes is
Yeah,
something that you have to consider once you put it out there.
yeah,
So
quite
I think
quite
it's like
often
there's
it's
a
like the fun is when it's in your own on your PC, like you can do whatever you want, you can refactor everything.
yeah,
But the day when you start to worry about binary compatibility, that's where sometimes like the fun like goes a bit out of the project, because it's
sure.
cool when people use it, but it's also as a maintainer it's a bit like tedious work. Like it's not sometimes you feel a bit like you want to make some changes but you can't, or you need to wait.
Right, yeah, yeah. So that's what I'm thinking. I'm like, if I don't, it's good to get it to a point where I think I'm happy with it before I push it to the repo, because after that I'm going to have to you run the risk of changing something that somebody's happy with. The only difference is that, like, say with Monocle, for example, you had a specific use case, um, which was in demand and people needed, right? So, being able to, like, um, you know, quickly change values in a nested case class and all that sort of stuff. I hope I haven't got it wrong, but yeah, I mean, that's what I've used it for.
Yeah.
Whereas with Sounds of Scala, no one's like going like, oh, I need this for my production code tomorrow. So no one's going to put it in the API tomorrow, and if it breaks, it's a big
Yeah.
disaster. It's a fun thing, and so I've definitely got like a lot more leeway than you do. But
Yeah, and
yeah,
the thing is that you decide to put like the level of stability. It's up to you to decide. You can, some people let the project in alpha stage for like years, and everyone agrees that I think it's all about like managing expectations. So as long as you tell people, I don't guarantee that this API is going to be stable. You use it at your
yeah,
own risk. That's fine. I think it's more like if you guarantee that, if you tell people you can use it in production, and then you keep changing everything, that's where people get angry.
yeah, for sure, and understandably.
Yeah, understandably, it's true. Cool. So, I also wanted to ask you. So, I read that when you were in uni, you wrote a dissertation around some kind of data analytic project around music, and you were trying to figure out if a song is going to be a hit or not. Is it correct?
Yeah, that's right. Yeah, that was like ambitious, but also pretty cool. And as someone who'd been like, working as a musician for it had been like 20 years or something more, I was definitely of the mind that you can't predict a hit song
Mm-hmm.
because there's so many different factors, and it's all about what it captures the public's imagination and attention at that point in time. But I analyzed what I did was I analyzed 80 one-hit wonders. And I captured all this data on them. Then I took the follow-up song from the same artist, right? So like this sort of follow-up flop,
Mm-hmm.
and then I like analyzed those. Like that was my data set. So I had like the happy path and the unhappy path, and then we could make a classification from them. And I'm actually like managed to get it to like make some good classifications on what a good song was. I ran it on a friend of mine's song, and it was a total flop. So he wasn't happy, but I mean, I didn't hear much from the song anyway. I did it like on Whitney Houston, "I Will Always Love You." It's actually not Whitney Houston, it's Dolly Parton, and that one came up as a huge hit. Like it was like the data that I did. Yeah, I mean, you'd have to like there's a little bit of like you'd have to say that the data be mildly spurious, just being honest. But it like definitely showed that there's qualities to a song that contribute to it being a hit. So I mean, I've got to be careful not to start going down a rabbit hole here. But I had to throw out some outliers. So one of them was the songwriter.
Yeah.
I think of the one-hit wonders, maybe 20, 25 or 30% of them, the first song had been written by somebody who was a hit songwriter, and then the second one was written by the artist. So an example would be Sinead O'Connor, Nothing Compares to You. Prince actually wrote that song. So the song was a huge hit, and then her song, which she released next, was not a hit. So just
I,
as an example, I had to remove those because they had a big influence. But once you looked at the musical properties, there were certain keys which featured more than others. There were certain lyrics that featured more than others. I mean, you can probably imagine the lyrics. It's not hard. It's like love and baby and yeah. Like
Mhm.
these lyrics feature in huge amount of hits. So
I see. And so, what
yeah,
was the input of your algorithm? Was it like, were you actually taking the music itself, or was it more like metadata around the song?
you'd have to. It was metadata because there's been quite a lot of work already done on this, analyzing sound properties. I think the MSCCs. I think. Um, this hit song science. It's a whole thing, and people have like gone right into it. Um, I didn't do that. I went for like actual musical properties. That's where it got a little bit complicated because there's no like software which can extract the chords and extract some of the data that I wanted to look at. So I
Mm.
wanted to like look at how the top line, like the melody line of the vocal, I wanted to look at how that interacted with the chords. So if the chord was like a C major, what was the singer singing at that point? Were they singing a C or an E or a G?
Uh,
So this was it. I was wanting to like really examine all these musical properties. It took me so long. Like, of course, we were in the lockdown, so I just sat there and I like hand transcribed or air transcribed 160 songs, and it took me so long. But I had these like yeah, I had to have ways of kind of encoding this data. So I can't even actually remember how I did it with the vocal line. But I think, for example, the chorus, when the chorus came into these hit songs, if the chord was a C major, then most of the time the note on the vocal would actually be a C as well, which is like the root
Mm,
note.
I think.
So if you're a composer, you don't really do that first and foremost because it's boring. It's like you want to go for a harmony, and I'm like you want to have like, so when the vocal comes in, it harmonizes with the chord. But yeah, so this is, I had all this stuff, and because I had to like have it like in buckets, right? So I'd have to say, well, so I'd say tempos of songs. I couldn't have like from 70 beats per minute through to 200. I had to have like regions. So I'd have like 70 to 90 and 90 to, so all this discretization. I really obviously am squeezing the kind of idiosyncrasies out of the music by doing that. But I still managed to find some really interesting patterns, and yeah, so I did kind of go down a rabbit hole there, but yeah.
No, that's very interesting. So you said that there is no public, at least like a repository where you can get this information from from popular songs. Like, so you can't like get like the notes for all the different instruments and vocals for each song.
I mean, I think that the data's out there, but collating it would be challenging. I think what we've got at the moment, unless somebody's done it and I don't know about it, is that it's really hard to extract chords from audio. I think
Mm.
the chord progressions are a key aspect of the composition.
Okay,
So
so you can't take a song and like essentially potentially do the other way around in your DSL, because your DSL like takes the note and plays it. You said that it's difficult to do the other way around, have the sound and create the DSL out of it.
um, so the DSL, it's I think I can go from like DSL to sound is no problem.
Yeah.
Like but having like the audio and then extracting the audio into the DSL, that's a challenge. I'm not sure that we're there yet.
Yeah, that would be very
I'm not
interesting.
sure that
But yeah, I guess
anyone's done that yet.
it's always more difficult
Yeah.
to parse than it is to produce. Like, but
Yeah,
yeah,
it must be doable because like a chord is still going to have like it's still going to be producing distinct frequencies, right? So C major chord is still going to be producing like a set number of frequencies. I just don't think we've had the technology quite yet.
and is it possible to extract like automatically the different like instrument from a song? Like, if I give you one track with all the voice, the different instruments, is it relatively easy to say, okay, here is just the guitar, here is just the singer, because everything is intertwined, right?
No, I think that's very hard too. You can do, with karaoke sometimes they use like the stereo um signal and they like flip the phase and it cancels out the middle, or you can use phase cancellation to remove certain
Mm,
parts of a song, but it doesn't. It's like the trick they had with the karaoke, but then the music sounds weird. So I don't think you can extract. No, I don't think you can. Like again, unless somebody's done it, like well, while I was too busy like learning Scala, I think that I don't think you can do that. Yeah.
that's interesting. And I guess there is no one that publishes a song as a series of different tracks with each track is each instrument, right? You get the final product, but you don't. There is no one that will give you something broken down, right?
You
Sometimes
do
you get
you
like
do like
yeah,
yeah,
sometimes you
you
get
can
the
ask
song
artists.
without the singer, but you don't get
Yep.
like one with like different instruments.
Yeah, I mean, this is a very interesting discussion because I did this for my friend recently. I had to go back and I opened up a song session from like 2012, and I was so upset about it because it took me so much time. Um, and he went and I had to load it up, mute the vocals, like turn the vocal tracks off, and then export the song so he could just have the instrumental. So that's what if you're an artist who's got a publishing deal where they might use your music in a TV ad or a soundtrack for something, play it in the background at a sports event, something like that, they don't want the vocals on it, then you've got to have the instrumental. So when you bounce out your track, um, you do one version as the full mix with the vocals and everything, and then you do another instrumental version and an a cappella version that you can give your publisher so that they can, use it
I
in
see.
different, sort of money making capacities. Yeah.
What is the standard format for like a recording, like, storing this song, like as in like let's say in photo, I think it's a raw format that where you can still
Yeah.
tweak it. Is there an equivalent for music or
Yeah, I'd say that it's probably still the WAV file.
wait?
I
Okay.
mean, there's been a bunch that we've used over the years. Like when I was first doing digital audio, it was these Sound Designer 2 files. They were high definition, I guess, like full quality digital audio. It kind of made way for like AIFFs and then WAV files. I think WAV file is the full resolution digital audio.
Mm-hmm.
Of course, most people use sort of MP3s. I think streaming's largely, I think, still MP3,
Yeah, probably.
but you can get like quite high quality MP3s. I think, you know, my audio engineering mates will cry, but they sound pretty good.
I thought like it was meant to be, I mean, there is of course like you lose some data, but I thought that it was not supposed to be hearable, like the data that you lose, like. But I guess it depends on your quality of your musical ears, I guess.
Sure, yeah. I don't know. I think mm, all you have to do is listen to a bad MP3, and then you can understand what data you're listening. You can hear these kind of jingle bell sounds on the top, like this sort of chiming. I'm not sure what I'm
Mm-hmm.
doing with my hand here. I was trying to do jingle bells, I think. But yeah, you can definitely hear some loss. I mean, yeah, I was obviously being in the sort of studio environment and being an audio engineer for a long time. I listened to a lot of people talking about audio quality. So when you would record it, you'd pay a lot of money for these analog to digital converters and have really good preamps because you wanted to capture as much of the sound as you could and have it converted into digital audio as smoothly as possible. All had to do with sort of the clock that you had in your analog to digital converter. So it's a really sort of big field where people spend a lot of money for
Yeah,
marginally improved results.
little.
But you imagine that you've got a track and it's got 40 tracks going. The cumulative effect of having a
Mm.
poor audio signal on the first track and then spreading it across 40, you can imagine you're going to get this. You can imagine it's going to be lower quality than if you have the very best and then times that by 40. So
Yeah, of course. Yeah, it compounds. It makes
yeah,
sense.
yeah, exactly. Yeah,
Another thing I wanted to discuss with you, I mean, it's completely, I don't know how familiar you are, but nowadays, like like the fancy stuff is like LLM, like in AI. And
yep.
one thing, because I'm not an expert at all in this area, but I was listening to someone was explaining a bit how it works, and that it's mostly text based at the moment, and one from what I understand, the way they train this model is that they take existing text, they corrupt them, like they hide some words or hide some, yeah, so some part of the text, and then the algorithm, I mean the model, is trying to guess what will be the word that were erased, and then you can train yourself because you know what was the original word. So I was wondering if something can be done similarly with music, because if you do have the original music track, you could potentially hide or corrupt the music, like hiding some notes, and try to train a model to same like guess what should be the next note, and then make some kind of generative AI for music.
Mm.
Do you think it's something that potentially could be used? And I think in this sense, your API, I mean, your model would be quite cool because it is a textual representation.
Yeah, I totally think that's possible. I mean, the things you can do, say using the Open AI API. Actually, you know what? Maybe I can show you this. I'm not sure if it quite um sort of covers what you're saying, but I'll show you anyway. Let's try this. Yes, if I go here, um, if we go up here and have a look at this, right? I have this bass line,
Mm-hmm.
four E notes, four G notes,
Yeah.
you know, um, A, G. So I'll play it again, see if we can. Actually, I don't think you can hear it, so I'll just show you. But you see how you have like a harmonized piano in thirds? If I come here and I start writing this in, the Copilot will try and do something. Yeah, look, so it's come in and it's copied it, right?
Mm-hmm.
So it hasn't harmonized it at all. But if I put in the first harmony for G, for E, sorry, so in an E chord, you've got like E, G, and B. So if I go G3 dot medium, there we go. It
Yeah.
finishes it off for me. And see, G, so B is the third, it is the harmony. D's not. The D's not what you want. You actually want it to be C, but it got the G right. So I mean, this is something that we're quite used to. We're getting some results that are not quite right, but it's getting there.
Yeah, it's definitely improved. I mean, it's a bit like sometimes
Yeah,
Excel has also a bit this magic when you ask, like, can you please, like, you give a couple of columns and then figure it out the rest. Like, it's quite good at figuring out patterns.
yeah,
Um, but yeah, I just wonder, like, because in a sense, you had like some kind of data analytics that were able to figure out is a song going to be good or not. And on the other hand, we have some LLMs that can potentially generate, like, find out what will be the next note. I imagine that in the future you could potentially combine these two to generate music and find out like good ones.
yeah. I think it's totally possible. I expect it. Um, I mean, at the moment, right, with AI, it's been like it's been a very we're going through some sort of like technological industrial revolution or something at the moment. Everyone's fascinated with just how much human interaction we need for a great number of things, right? So you
Mhm.
see it like every day. People talk about, what's your software engineering role going to be like in 1 year,
Yeah,
5 years,
we don't
10 years?
know.
Yeah, well, so it's the same, I think, with music. It's like, when's the first AI generated hit going to come out? It's like, I mean, so I, most people would
What would be your
believe,
guess?
well, like, look, there's a guy, Max Martin, who produces all those really massive pop songs for, I think, Britney Spears. He did it for The Weeknd. And like, if you look at Max Martin, he's produced this huge amount of number ones. This is one person who did it. I don't think there's any conspiracy. I just think he knows how to write a really great song, a really great pop. Well, yeah, he knows how to write a song that's going to ship massive amounts of units, right? So that suggests there's an algorithmic process, right? So if he's got it, then I'm quite sure that like an AI can do it closely. But one thing is that I'm not sure if there's any hit song at the moment that hasn't got like a human interaction. Like usually got a vocalist, and the vocalist is the one with the character, right? So the
Hmm.
vocalist is the one that's selling it. Yeah. I mean, there used to be a thing I think in the 80s and 90s, where if things are programmed, that they sound stiff, they don't sound real, and they sound crap. But as time went by, like more and more programmed stuff, became the norm. And so like all this music on the radio and that, like at the moment in the sort of top 40 charts, there's loads and loads of digitally generated sound. So
So
yeah, I
how
mean,
much?
I
Yeah, I'm curious. Like, so how much do you reckon is the like let's say like you're able to generate like one hit track like on paper, like it's gonna be good, and you give it to different interpreters, like even good ones. Like, how much is the importance of the singer, a particular singer to make a hit? Like, do you think is it very important, or is it like more important is the
yeah,
beat and the yeah?
absolutely. All you have to do, right, is like all you have to do is take one of these really amazing songs, and then you get one of those people that go on to X Factor and can't sing, and you
Okay.
just get them to sing that song, and it's unlistenable. So I think that you have to like you do have to have a great singer. Like I mean, I've experienced this firsthand too. You have a really great singer, people they just want to listen to the sound of their voice. That's the engaging thing. However, and have there been like sort of hit songs released that had no vocals? Well, yeah. So I just played Daft Punk before. Like that,
Hmm.
that was kind of a hit song. So Daft Punk had songs without any actual like vocals in it. So it can be done, right? Like a pure instrumental track can be a hit. So I mean, I do obviously I think it's quite possible and it's quite likely.
Nice. Cool. Yeah, I think like I guess like AI is going to revolution like so many areas, and music is one of them. So it's going to be interesting to
Yeah.
see what's going to happen.
Yeah, I
But
mean, I think Billy Corgan from the Smashing Pumpkins. I mean, this is like a secondhand quote. Someone else said this to me, but he was saying that the way that he wrote songs, he'd borrow ideas from other artists anyway. So now with AI, it just makes the borrowing a bit quicker, and there's probably always going to be some human intervention. Um, yeah, so I guess just adapting and using these new tools. But like, yeah, I think the one question which you asked, which is are we going to have like a hit song which is purely AI generated? I mean, that's the big question.
Yeah, I mean, it doesn't
Probably,
necessarily need to be like
probably
100%, but if you can do like a, like, you know, filter a lot, like do all the generation, like give you maybe just the track, like, and then you have to interpret it. It's already like a big chunk of work, like,
for sure.
and also like the studios, like, you know, it always like impresses me, like all these knobs, all these things you can tweak. Like it seems like, yeah, very manual, and I just wonder how much of this can be automated, or you know, at least, you know, improved. Like,
Yeah, we totally like automated it all anyway. Like we like once honestly, I think there's a period as well. Like, I think a lot of the big studios started closing down because people were just using their computers and doing everything inside there. So that already happened. Like, and you automate all this stuff inside your you manually automate it. I think yeah, so it's all very possible that you can
cool.
increase that level of automation to include AI. Yeah.
Well, thank you very much, Paul. It was super interesting. I really encourage people to try out Sound of Scala, and I think you have like some open issues that, you know, people could tackle, or some kind of tags that are relatively to help people to, or what would be, what do you recommend for people who wants to get involved, essentially?
Yeah, we do have so basically we've got a Discord which you can get to from our repo and just join that and hit me up and I'll make up some tickets again this week. Just some nice little bite-sized tickets that people can do to sort of just get involved and try some things out. Like I mentioned that one about the octave to you before. That's something we actually need to do, is implement like an octave for oscillators. So I won't get the details, but
No,
yeah,
no, no, it's
I'll
nice.
have some nice small tickets and we can share them out.
Yeah, for sure. So anyway, I will add a few of these links below the video. If you have also like links you would like to share to your Discord, anything. It was very interesting to talk to you, Paul. I really appreciate you to have you. And
Oh, no worries. Thank you very much for having me.
yeah, you're welcome. And so if people you're interested to sponsor this channel, like don't hesitate to check out our sponsors. And yeah, I hope to see you soon on the channel. Bye.